Okay, the first thing I need you to do is take out your periodic table, and we're going to look at something we've not looked at before. Has anyone ever wondered how I know how many vertical lines to put? Okay, thank you. This will tell you. I call this thing the map. So have it out, and we're going to learn how to read it. A map requires two things, pretty much. That you know where you are and you know where you want to be. That's all you need for this. And when we say you know how, we mean you need to know the starting unit I give you and the ending unit of your answer, and then life's fine. So the first thing I need you to do is to put a vertical line right through the middle of it. That line is there because it always has to be crossed. If you do this process and you have not crossed the line yet, then you're not done. Are we okay with that so far? Oh, you're there. Sorry, I don't know what I was thinking. All right. The next thing you're going to do, in those two boxes in the top middle, I wrote the word liters. Will you write the words liters right there as well? Why? All right, so our liters right here and here. Oh, I'm going to swear. What the freak? If you pay attention the next 2 minutes, you shouldn't ever wonder how to know how many lines there are in your picket fence. So here we go. Today we're going to learn moles to liters, but I want to think about what we just barely did, which was grams to grams. So grams to grams had 3 vertical lines, correct? And this is how you know. You start on the given side with the unit I give you, which is grams. What am I asking you to solve for? Grams. But I have to go across this line, so I'm going to go all the way over there. Please look. I need to go 1, 2, 3 steps. Every arrow is a vertical line in your picket fence. Easy enough. When we started this entire process, we started by going from moles of one thing to moles of the other, and that was just one picket fence because we went one arrow. And then we went moles to grams, and that was 2. And then we went grams to grams, that was 3. Today, we're going from moles to liters. I always want you to cross right here. So we're going to go over and then up. So how many vertical lines? It's already drawn. 2. Easy enough. Now, there's a lot of information on this map. Some people it might be overwhelming, but the majority of you should be fine. We're going to do the same process. Now you just know how to find the number of vertical lines. And then the other thing that's of utmost importance is this right here and here. Please find that. All right. There is a constant. It's related to Avogadro's number. And it says for any substance in a gaseous state, 1 mole of it will occupy 22.4 liters. All right. So will you do one thing for me? On the 22.4 liters, in front of the word moles, put a 1. You should always have a 1 with your 22.4 liters per mole. And do you remember when we found something on the periodic table, I always said grams is 1 mole of the same thing. Thank you for making me believe in myself. Liters will be the same way. It's 22.4 liters per 1 mole of the same thing. Now, the 22.4 liters per mole is a constant. 22.4 liters per 1 mole of the same thing. But in proportion land, we don't care which way is which. It could be written 1 mole over 22.4 liters. So don't think just because that shows you 24 over 1 that it's locked in there. We can flip it around. And the way we know which way it goes is if this were mole here, then mole bottom, 22 liters on top. If this was liter here, then 22 on the bottom, 1 mole on top. So the previous unit in the picket fence tells me what goes there. All right, let's do this. So the first thing you need to do is balance this reaction. It's a combustion reaction. This is page 11, letter D. It's a combustion reaction. So start with the 2. All right, how many of you think you balanced it? 1. Okay, about 10. So hopefully you started with a 2. And look, I am aware that mine is backwards of what yours is, right? I wrote the products different, but it doesn't matter. 2 times 3 means you put a 6 in front of carbon dioxide. We okay with that? And then the 8 goes there, and you add that, divide in half, you get a 10. 2, 10, 6, 8. So who had that right? Oh, yeah, okay, 2, 10, 8, 6, whatever. This came forever ago, so it might be useless. All right. Now, just follow the exact same process we've been doing all the time. So, is this the 50 liters of O2? Okay. So look up here. Is that for Anderson? Nope. Oh. Right there. The beard. Okay. So please look. 50 liters of O2. Next time I'll know. Okay, now, sorry for the interruptions. No one watches these videos anyway, so who cares? All right. It's okay. Yesterday's video had 1 view. Probably me making sure it uploaded. All right, what unit goes down here? Liters of O2. And I just taught you, anytime you have liters, it's what number? It's a constant. 22.4. Oh, that's ugly. Whatever, liters of O2. And it's always per what? 1 mole of the same thing. Thank you. Then, if I know the top unit, I have to know the bottom unit because they're the same thing, right? So what's on the bottom? Mole of O2. Thank you. What am I solving for? All right, moles of C3H8. And that is the unit at the end also. And then I just find my values. What is in front of C3H8? A 2. What's in front of O2? A 10. I need to reduce them. I don't have to, but it will save you some calculator work. To 1 over 5. And then I'm ready. I take 50 and I divide it by 22.4 times 5. Did I lose your Hershey? Which part? It's okay. Which part? Okay. Did you need this? She's in the zone. What do we get? Is this the 0.46 or the 0.56? 0.45? My fault. I'm terrible. Okay. By now, the process shouldn't seem new. Like we threw in a new variable of the liters, but the idea, whatever's here goes down and over, down and over. Find the answer, bring it over till you meet in the middle and do the math. What do you think? What's wrong, Caleb? What did you get? Okay, you know why? Because you took 50 and divided it by 22.4, and you multiplied that answer by 5. But that's not. If anyone got 11, anyone else get 11? Okay, it's 50 divided by this product. Does that make sense? Okay, let's turn to our homework, as always. I do, we do, you do. That's the model we follow. So number 46, we'll do it together. It's a mole to liter again, so balance. It's a combustion reaction again. It's the most basic combustion reaction that we have. All right. It's a pretty short hour, so I'm going to hurry. If you don't have this balanced yet on your own, it's okay. You're not a failure. We're just going to go faster than maybe you are. Start with a 2. Balance carbons. Take the number with H, put it in front of water, add everything, divide in half, and you get a 4. 2, 4, 2, 4. Now, let's do the picket fence. How many vertical lines? 2. We're doing the same thing, so it's 2 steps, 2 vertical lines. Or slightly diagonal. Sorry if you're a perfectionist. I definitely isn't. Now, 2.25, is that this one? All right, 2.25. Did I give you moles or liters? Liters of which thing? CH4. Okay, now I'm ready to roll. I have a 22.4 liters of CH4. Liters are always listed per what? 1 mole of the same thing. Then whatever unit is up here always goes down and over, so mole, CH4. And then the last thing I need to know is what I want is my answer. What am I solving for in my answer? All right, mole of O2. So that means that's the unit at the end, mole, O2. And then we're going to find the O2 has a 4 in front of it. CH4 has a 2 in front of it. And then let's do some math. We can reduce 4 over 2 to just 2 over 1. So 2.25 times 2, and divide that by 22.4. Is this the 0.2 one? Okay. Who had 0.2? Okay. Now, I know I did it for you, but did the idea make sense? The process. Okay. The next one in the homework, is that the H2O and SO3? All right. So SO3 plus H2O makes H2SO4, and they just balance out. You just put 2 things together, so it's just 1, 1, and 1. Then you do the picket fence, and we'll check it. Check with your lab partner when you're done, and we'll go over it. Here is the science or the chemistry behind it. It's the decomposition of calcium chlorate, which is CaClO3, 2 goes to CaCl2 plus O2, and you need a 3, a 1, and a 1. And then once again, please do the process, not the memory from the last one, because it is exactly backwards. Okay, give that a shot. So once again, the key to this one is not trying to make it match the last one, which people did try to do. What did I give you? 34 moles of that stuff. I don't know what just happened. What are we calling that? That's like a, ugh. Better? Okay. 34 moles of that. Now, look, that means what unit comes down here? Mole of CaClO3 2. Okay? I'm lazy, so are you. Now, most people that get this problem wrong, they're like, hey, moles, which means 22.4. False. There is nothing here. I try to say this a lot. There's nothing here that tells you what goes there yet. And don't guess, don't assume, don't think you figured it out. Go to the end and work your way back, right? So you're solving for what? Liters of O2, which means what's over here? Liters of O2. And liters are always what number? 22.4, and they're always per what? 1 mole of the same thing. Now, is there something that tells me that goes in the top middle? Yes, there is. You will always be told what to do. Don't guess. Mole, O2, that's a 3. That one's a 1. 34 times 3 times 22.4. 2284, right, Penfold? .8, my fault. Let's see, I was off 2,284th. Okay. Does that make sense, Jules? Jada? The other people that got it wrong? Does it make sense now? Don't guess, just fill in. Yeah. And you got it right? It's fine. You can do this wrong, but put the numbers in the right place, and you get lucky. So, Liam and everyone, what he most likely did, what, like I guarantee you did, is you went here, then there, and then there. That's fine. But to make the units work perfectly, you want to go over and then up. Does that make sense? So there's 2 ways to get there. You just did it the other way. Okay. Thumbs up if you're all right with this. Okay. Or thumbs on your keyboard. That means you're good to go too. Perfect. Thank you. All right. We got probably 5 minutes left. Is that right? Okay. Let's do the next one, which isn't any harder. Who's figured the process out now? We're just going to follow the process, and we will not go astray. Here we go. I've done so many of these. Oh, my. Woo. Okay. Is it this one? No, it's not. Forget it. We're going grams to liters, right? So I just want this map. Ignore this for a minute. I can't delete it because I locked it. But please look at me. Shh. Grams to liters is going to be longer. Look. Grams of given. I go over, and up. How come I didn't go over and up and call it good? I didn't cross the line. And I want you to always cross the line there. So this will have how many vertical lines? Ignore this one because it's not this one. 3. So first thing first, balance the equation. Is this the Li plus O2? Okay. Did I do it wrong? No, I'm on the notes on page 11. Yeah, my fault. I'm right here. Letter E on page 11. It's all right. Then I'm going to balance it with a 4, a 2, and a 1, right? Okay, 4, 1, 2. Okay, now, just stick with me. It's the same idea. What did I give you to start with? 23 grams of Li, which means what unit goes on the bottom? Grams of Li. And grams is always listed per what? 1 mole of the same thing. If I know the top, I know the bottom of the next one. And that's moles of Li. But then I'm stuck. Don't guess. Do not guess. I go backwards. What am I solving for? Liters of oxygen. Almost always, by the way, we're solving for liters of oxygen. So we'll come over here. liters of O2. Liters is always what number? 22.4. And that's always per what? 1 mole of the same thing. If I know the bottom, I have to know the top. That would be mole O2. And I've met in the middle. I just got to fill numbers in. What's the big number for lithium? Rise with heaven. 7. All right. And then the moles O2 come from right here. A 1. The moles of Li are right there. It's a 4. Multiply the top, multiply the bottom, and divide both answers. Okay, what do we end up with as our answer? 18.6, right? What? 18.4? Okay, pretty sure 8.6 is an answer to your test. Remember that. 8.6. 18.4 is your answer. 8.6 sounds super familiar in my life. Like, I think it's the answer to problem 55. Is that weird? It's 54, 55, or 56. Okay, raise your hands. We went through that fast, but who's okay with that? Well, this one's pretty easy.